All right, ladies, gentlemen, children of all ages, anybody else not covered in the opening statement? Today you are going to spend some time reviewing for your test. Just as a couple of reminders. Number one, anything you have written on your yellow periodic table or on the pink solubility chart can be used during the test tomorrow. You don't have it written on there, you cannot use it. Okay? Tomorrow, your backpacks will go up in front again, just like before. Let's take a look here. There are a total of 15 questions, including 7 points worth of bonus questions. So those 7 points can add another 10% onto your score. Yes, I'm going to ask you to define chemistry. The definition I gave you at the start of the class. Okay? Number two, we're going to ask you about kinetic and potential energy. You should know what makes something have kinetic energy. You should know what makes something have potential energy. You should know what factors affect kinetic and what factors affect potential energy. There are 2 for kinetic. There are 3 for potential. You should know how it is possible for 2 things to be at the same temperature and yet have different velocities and different masses. If you are at the same temperature, you should also know what temperature means, which is it is the average kinetic energy in the particles of matter. So 2 things could be at the same temperature. They could have the same kinetic energy. Doesn't necessarily mean that they're moving at the same speeds. 2 objects can contain the same amount of heat, but be at very different temperatures. Because heat is the sum of kinetic energy, not the average. Therefore, heat relies on the temperature, or how fast the particles are moving, and it also relies on how many particles are there. You should be able to give me examples of an object that has kinetic energy but no potential, has potential but no kinetic, has both kinetic and potential, and has neither. I will ask you to tell me the differences between kinds of properties in 20 characters, meaning letters or less. Not expecting a complete sentence. I'm expecting you to be able to put 20 characters together and tell me the difference between different kinds of properties. Okay? So you are literally going to create a hashtag, and there are literally 20 spaces here, and you cannot go over that 20 spaces. And then you will give me examples. Examples of chemical and physical changes. Examples of chemical and physical properties. Examples of intensive and extensive properties. So you should know all of that, ladies and gentlemen. You should know what the signs of a chemical change are. That was the lab that we did on the copper chloride. We talked about graphing at the start. There are two different ways of looking at the relationship. We can look at a constant versus a non-constant. We can look at inverse versus direct. And you should be able to describe, draw, or look at a graph and tell me which of those 2 relationships it is when you look at a graph. You are going to have to classify matter. That means it is either a substance or a mixture. If it is a substance, there are 2 kinds, element or compound. If it is a mixture, there are 2 kinds, homogeneous or heterogeneous. And you should be able to define them and give examples of each. You need to tell me what the parts of an atom are and what their purpose is. We talked about 2 laws, conservation of energy and conservation of matter. You should be able to explain them to me. There will be a problem on there where you will have to find either the density, mass, or the volume of some object. You should know the assumptions of KMT, kinetic molecular theory, and how kinetic molecular theory relates to temperature, heat, mass of particles, and speed or velocity of particles. And then there are the 2 bonus questions, one of which is 3 parts. Questions, ladies and gentlemen? Any of that stuff that we just talked about that you want me to clarify for you, that you want me to explain better or go over more? Nothing? You have three things to do then, ladies and gentlemen. Number one, make sure your yellow sheet and your pink sheet are filled out. Number two, in the back of the classroom at each lab station, there are three questions involving density, very similar to what you will see on the test tomorrow. The chalk markers are in the back. There are towels out. You can wet the towels down. If you want, you can either grab a piece of scratch paper or you can do your work right on the lab station. I would suggest solving all three problems, because if you can do all three of the problems, you can do the one that I will give you on the test tomorrow. To make life easy for you, ladies and gentlemen, when you are done solving your three problems, at the back of the middle lab station, there are 4 answer keys, one for each of the versions of the questions that are out at the desk, so you can check and see if you got them correct or not. Be careful, 4 IDs are up in the corner, A, B, C, and D, 4 different answer keys there. Please do not write on any of the sheets. Please do not write on any of the answer keys. If you get to something and you don't know why I got the answer the way I did, call me over and I will go over things with you. That is number 2. Number 3 is starting on slide 90 in your notes, ladies and gentlemen. There are 10 slides to 100 of review questions. Some are multiple choice, some are fill in the blank. At the end of the hour, I will take the last few minutes to go through and provide you with the answers to those 10 slide questions. Go to work, ladies and gentlemen. Go to work. If you have questions, if you need help on anything, please raise your hand, call me over, and I will be happy to assist you. Calculators are up here. Take one if you need one. Just make sure you put it back before you leave. Ladies, gentlemen, children of all ages, I would like to go over the questions at the end here with you real quick, so that those of you who looked at them can know what the correct answers were. This first question on slide 91 will not be on your test. I did not get to specific heat with you. So there will be no specific heat problems. If you looked at the end of the unit, there was some specific heat. There were some problems about water temperatures and things like that. We just didn't get to that. So that will not be on there. So this question will not be on there, even though the answer was all of the above. Okay? A question like this will be, now it will not be a multiple choice, but 2 objects at the same temp are moving at the same speed, have the same specific heat, have the same potential energy. None of the above. None of the above. Now, it is possible that 2 objects at the same temperature could be moving at the same speed, but they would have to have the same what? They would have to have the same mass, and because we don't know that here, none of the above would have been the best choice. Again, a specific heat problem, we won't look at it, we won't worry about it. But this one, Which line represents the substance with the highest density? Now, in reality, there are only two choices here. What are they? Orange and blue. There's no way the middle line can represent the highest or the lowest because it's in the middle, correct? So you're really debating between orange and blue. So what I would tell you to do, ladies and gentlemen, since density is mass divided by volume, if we pick a volume, the one with the largest density is the one that has the largest mass at that volume. Therefore, that is the orange line. Okay? Which of the following depends on the amount of sample present? More than one answer may be acceptable. Which of these depend on the amount of sample present? Mass, volume, density, specific heat. Let's take out specific heat because we didn't get to it. Which of these will change if you have more water in a cup? Right? The volume will. Anything else? Nope. The mass will. This is the definition, ladies and gentlemen, of an extensive property. One of the type of properties you need to know on your test tomorrow. Extensive properties are properties that depend on the size of the sample. Mass depends on the size of the sample. Volume depends on the size of the sample. Density did not. We learned that in our lab. Small object, large object. Yes, they will have different masses. Yes, they will have different volumes. But when you take their mass divided by the volume and do density, they will be the same. They will be the same. That's why our density was a straight line. Again, somebody asked me, what are some things that are going to be on the test? There is a list of them for you, ladies and gentlemen, besides the ones, again, I went through it at the start. I was reading the test to you at the start. That's what I was looking at as we were going through those topics. But again, here's another list of them. When heat is added, what happens to kinetic energy? Kinetic energy increases. If you add heat to a substance, its kinetic energy will increase. The only way it will not increase is if the substance does what? What is the only way kinetic energy will not increase when you add heat? Give you a hint. The graph that went up, leveled off, went up, leveled off, went up. When it was leveled off and going horizontal, you were not increasing kinetic energy. You were going through a phase change. Very good, Jay. Very good. That is the only way that that does not happen. What happens to the particles when heat is added? They move faster. They move faster. When is the only time this is not true? When you're going through a phase change. When you are going through a phase change. And that line levels off and the temperature is no longer increasing. Why do things that are heated expand or take up more space? Why is it when you heat things up, they get bigger?
Doesn't it just like the molecules expand and they become like more, they move faster?
They don't expand because the molecule size is the molecule size. But you're right about them moving faster, right? Well, when temperature increases, that is when things are heated. When they start moving faster, as they run into each other and bump into each other, they hit harder, so they move a little bit away from each other. As things are heated up and they get hotter, as the particles move faster, they take up more space. This is why in summer you will hear about blowouts in the pavement on roads. The road literally is trying to expand and it has nowhere to go, so it will buckle. Next time you walk down a sidewalk, take a look at the sidewalk. What do you see every few feet? You see a big old crack. It's called an expansion gap. It allows the concrete to expand on a hot day. Okay? It is not a lot that it expands, but it is enough that it will literally break apart roads and break apart concrete and things. Okay? So, the particles move faster, hitting each other harder and more often, moving them further apart from each other. All right. Explain how KMT, energy, and heat are related. KMT says matter is made of particles that are always moving. That is what KMT says. 2 points. All matter is made of tiny particles. They are always moving. Heat will cause the particles to move faster. Heat will cause the particles to move faster. Because heat is a form of energy. Energy will increase. The kinetic energy will increase. Why? Because the particles are moving faster. If something moves faster, that means it has more kinetic energy. So, heat causes them to move faster. That increases their kinetic energy. And this all happens because we're looking at matter in terms of the tiny particles that make it up. The atoms, the molecules that make up the matter. Okay? And that is the way we explain the relationship between energy and matter. Energy makes matter move faster. Question. Tomorrow when you get here, ladies and gentlemen, take out your yellow sheet, take out your pink sheet, take out a calculator, take out something to write with, get to a desk. Your backpacks and your phones come up here. As soon as everybody is ready, we will start the test. Give you as much time as possible because you only get the hour, ladies and gentlemen. Okay? Yes, I did. Oh, I didn't know if you needed something. Sorry.